Hi, I'm Bob. Let's continue our solutions to computer exercises for Chapter 9. In exercise number 6, we redo example 4.10 about the salary-pension trade-off for teachers. We can estimate the three models as in the textbook. Then we find that 4 observations have less than 1% of the benefit-salary ratio. They are dropped from the model. Next, we re-estimate the 3 models. We store the results for each regression by the estimate store command and display them using the esttab command in Stata. We compare the estimates and find that the absolute values of the coefficients on the benefit-salary ratio drop without the 4 outlier observations. And the salary-benefit trade-off hypothesis is more likely to be rejected. For example, we test for the null hypothesis of beta 1 equal to -1 for model 3. The t-statistic is 2.95 and its p-value is 0.003. We reject the null hypothesis at the 1% level. By contrast, the null hypothesis is rejected only at the 5% level without dropping the 4 observations. Let's find answers to computer exercise 7. For part 1, out of 1,989 observations, 205 have other debt obligations of more than 40% of total income. We re-estimate the model with and without the 205 observations for part 2. We use the esttab command to show the estimates table. The t-statistics are in the parentheses below the estimates. We compare the estimates and find that the change in the coefficient and the t-statistic for the variable y is negligible. For part 3, the estimated coefficient on y is not too sensitive to the sample used. Let's do computer exercise 8. The sample mean of the total standardized test scores is 0.0475 and its standard deviation is 0.8535. We estimate the simple regressions in part 2. Only the years at a 4-year college is positively and significantly related to the test score. In part 3, we test for the null hypothesis that the return to school is identical for 2-year college and 4-year college. We estimate the models with and without the test score variable. We can use either the test command or the linkum command in Stata to test for the null hypothesis. Without the test score variable, the one-sided p-value is 0.07, so we reject the null hypothesis at the 10% level. With the test score variable in the model, the one-sided p-value becomes 0.21, so we could not reject the null hypothesis that the returns to 2-year and 4-year colleges are the same at any reasonable significance level against a one-sided alternative. For part 4, the t-statistic for the test score squared is 0.4 and its p-value is 0.69. It is not statistically different from 0 at any conventional level. Besides, the adjusted R-squared drops slightly, so we should not add it to the model. For part 5, the F-statistic for the joint significance of the two interaction terms is 1.96, and its p-value is 0.141. The two interactions are statistically insignificant at the 10% level. We may consider dropping them. Therefore, the final model will be the model in part 3. Thank you so much for doing the computer exercises with me. See you soon. Thank you for watching this video and subscribing to my YouTube channel. See you next time.